Welcome back everyone to the Hello World Guide. This is another episode of the 3D render series in which we are implementing lighting and shading and materials in our 3D render. And as you can see here, I've got my structure called material here, and because this in the previous video, but I moved it from object.h to model.h because the materials are going to be handled here. And in the model I added a new thing, a new vector of material called materials. So yeah, but there basically be a bunch of materials because each scene that we load will have a few materials in it, and each mesh will also store a size underscore t for material index, an unsigned integer representing and we'll just initialize it to the default in the constructor here, and it will represent what value of the particular vector we want our material to get. So we'll have it like this here. And now what we can do is we can go back under model.c, and you can see cpp here, and you can see we have got all of this, and we are loading each of the nodes and each of that correctly, and that's working. But what we need to do is we need to also get the actual material index for this. And if I go ahead and for example, you can see in here we have got a process mesh function, and what we are going to do is we are going to for example, let's go under mesh.cpp and allow it to initialize the material index directly in the constructor. So we will create a extra argument here called material index. Let's just call it the material index, and we are going to paste this here, and we'll just initialize it to that like by default, like we are supposed to do it. And what we need to do, of course, is we need to make sure that we update the signature of this in the header file as well, but we are not going to make this a mandatory argument. Instead, by default we are going to set it to 0. Alright, now let's go back under our model.h and our model.c in here, and you can see that we should be able to provide it with a material index as well. Now we have got our mesh here, so if I get that mesh, our AI mesh here, and you can see if I go ahead and get this, you can see it has a bunch of stuff, and if I go ahead and try to type out our material index, then that is a and that is present in the mesh as well. And you can see, as it says, a mesh uses a single material, and if it uses multiple materials, then they are automatically split up into multiple meshes, and we are going to use that as an index. And we don't really have to worry about the index getting out of bounds, because it should not be out of bounds here, and it should not ever be like this material should never be empty. It will always contain at least one material, because every proper scene that's loaded properly will always have at least a single material. So we have got all of this, and we are pretty much loading our material indices correctly. Now materials are different since they are stored in the scene, and every mesh can access them by their index, so we need to have a separate function for loading all of our materials. So let's go and implement that. Now inside of our model.h file, we are going to create a new function which is going to similar to be process mesh, which is going to just write out its signature here. It's going to return a material, and it's going to be called process material, and it's going to take an AI material pointer, pretty similar to how we handle everything else. And we need to implement this inside of the cpp file. We'll do that here, and we'll just leave it at default, and let's go ahead and first learn how to call it correctly. So what we'll do is after we are done with processing the nodes, we'll run a loop over the scenes materials. So we'll basically get scenes number of materials and run a loop over them, and we'll just call process material with scene m materials, and we'll pass in I here for the index, and we'll just get the array access directly, and then we'll push this back into our materials vector directly, and we can remove these because we don't really need them. And yeah, that's pretty much all we need to do. So if I go down here, you can see we have got our process material function, which is currently empty. I'm going to actually change this name to be mat because to avoid confusion of any sort. What we are going to do is we are going to create a material here called material, and in the end we'll just actually material, and in the end we'll just return this material. So return and material. Now that is pretty awesome, but we of course need to actually in here we need to populate the material property. So yeah, we need to figure out a way to do that. So for that we need to kind of access that stuff from inside of this AI material that we have got. So if I go ahead and open up the material.h file, you can just control click on it to open it up in Visual Studio, and actually examine how the material structure is implemented. So we have got this structure here called AI material, and you can see inside of here it has quite a few functions here. So you can see there are a lot of functions. So what we need to do is we need to use some of these functions, and in here you can see they have got the most important function that we really care about is that these get functions here. So for the very start, you can see that we have got we have got a function which will retrieve an array of type values. We don't really need an array. We'll just get each material property directly, because a material is just like a map of properties. You can think of it that way. And if I go here, you can see that and this is pretty much how it does. So we have got this function here which is called get, and it has a bunch of different overloads. One is a templated one and others are not templated, and we can use these to get different kinds of values. And what we need is, in our material we only need three kinds of values here. One is the diffuse, one is the specular, and one is the shininess component. So how are we going to access these values here? We need to figure that out and then do that inside of here and set our material to the correct properties according to what we need it to be. Now the get function of the material takes in different kinds of stuff like referencing depending on the type that we need. So what we'll do is we'll create an AI color 3D called just COL for short for color, and what we'll do is we'll call mat get, and we'll pass in AI mat key underscore color underscore diffuse. And now this get function, you can see, takes in 4 arguments, but what we do is, this is a macro that we are supposed to use which passes in 3 of the arguments automatically, and we need to make sure that we use these keys because we actually need to use these keys, and all we need to do after that is we just need to pass a reference to the structure that we want to fill. We'll just pass in our color that we have got here, and then we'll set our material.diffuse to a glm-vec3 which we can easily get from that color by getting its individual RGB components. Similar stuff can be done for specular. Now for the shininess, we can just pass in our material.shininess directly, since it's just a basic float and nothing else. And yeah, that's pretty much it. We have got everything done here, and our material processing should now be working, and we should be able to go ahead and push them back in our here as well. And that's pretty awesome. But the only thing that's left to do is actually learn how to apply these materials. Now for applying these materials, currently we had them on an object basis, but we will need to change that and move it to a mesh basis, because now we have got materials per mesh, not per object. And we are going to make the materials draw function take in the meshes draw function take a material. And you might say, okay, that's pretty awesome, but another way to do it is to actually not have it take a material at all, and this is actually the better way in my opinion, and I will remove this here as well. But instead what I will do is I will just let me cut that, and I will go ahead and basically remove all of this code and just call the model draw method. And the reason we do that is because now we'll go inside of model and we'll implement this here. So let me go down to draw function. Yeah, here we have got our draw function. Now when we are setting the value of the model matrix, we will also set in the value of every other matrix. And for the actual material that we need, we'll go ahead and say we'll say material, and we'll take it at a reference, but a const reference, because we don't need to modify it, but we only need to kind of get it. And we'll set our const material, and we'll set that to we'll just say we'll say materials, and we'll get our materials array and access it according to the mesh's material index. So we'll say mesh dot material index, and we'll get that material and we'll set its properties correctly. And actually we need to provide it with a name, of course, so material here. And that is pretty much all we need to do. That should actually cause each material each object to have to work it will now be able to work with a different material. Now what I did was that I modified the Blender file a bit to kind of include separate materials as well, and if I run this file right now, you can see that we do get the material, and every object is colored like I made it inside of Blender. And you can see we can get some specular highlights on the monkey head and also a little bit on the sphere, but there are practically no specular highlights on this little floor that we have got here. The reason is that I set the shininess factor, the actual roughness in Blender, it was the roughness. I'm pretty sure it translated that somehow, and you can try experimenting with different file formats as well, because different file formats have material stored in different ways, and sometimes it doesn't always work that well, but most of the time Assimp should be able to get everything to work correctly. And yeah, we have got this, and that is pretty awesome. Now we are able to load each material separately. So yeah guys, this is pretty much it for this video, and in the next video I'll see you, in which we'll worry about some different things to make our game not game actually our 3D rendering application look a lot better. So stay tuned for that, and make sure to like and subscribe as well, and share this video with other people, and bye.